So one last panel session for you, and today, welcome. It's our performance monitor panel discussion. We've called this Transform IT Data into Operational Intelligence, a modular approach to monitoring network and trading application latency. So I wanted to start off, we're really at an exciting time here in networking. We're at 40 gig at the servers. We've heard about the new server technologies already launching. We heard quite a bit already about the latency, coming to zero latency, the importance of things like compliance and security requirements growing in our businesses, and network visibility becoming more and more critical. So, and we heard, and we know application latency is business critical. So today, happy to host our panel here discussion, and we're going to introduce our panelists here. The first panelist to our far left is Fergal Toomey. Fergal is one of Corvil's founders and a specialist in bandwidth and QoS measurement technologies. He has been involved in the design and development of innovative traffic measurement and analysis algorithms for the past 12 years. At Corvil, Fergal has been intensively involved in developing key product innovations directly applicable to managing IT system performance. Recently, he has been involved in applying these innovations in the enterprise sector to help our customers realize the full capabilities of the product. Welcome, Fergal, to the panel. Our next panelist is Richard Croucher. Richard has VP of High Frequency Engineering. He's many years of experience of banking IT systems in both consulting and permanent roles with Barclays, Commerce Bank, Credit Suisse, Deutsche Bank, HSBC, Flow Traders, Merrill Lynch, and RBS. He's experienced at all the layers of infrastructure and with devices from smartphones to mainframes. He programs in multiple languages, having started with assembler on his self-built computers, transitioned through Pascal, C++, Java, and C#, and is now a strong proponent of Erlang. He was also chief architect for one of the first cloud-based grid offerings designed to support banks, and was lead architect in the DevOps cloud team at Microsoft, and has helped several cloud startups. Richard is also a fellow of British Computer Society and a fellow of Stack Research. And finally, closest nearest to me, to your right, is Matthew Knight, Director of Technical Marketing Financials at Solarflare. Before joining Solarflare, in January of 2014, Matthew was the company president of Ascensus, a company building ultra-low latency hybrid software FPGA trading platform. And prior to that, he worked at DRW Trading in Chicago in the role of head of labs, focused on ultra-low latency technology. And before that, he worked at Stack Research in its early days, following almost a decade at Reuters. So, welcome to our panelists, and let's step to it. Thank you. Well, it's pretty apparent that performance monitoring can mean many different things to different people. So let's start with that. Like each sort of you tell our audience what you think the definition for monitoring performance and trading application latency means to you. And we'll start with Richard, who's represent the customer perspective here.
So from a Barclays perspective, so I'm part of the specialized trading team at Barclays. So we look after all the high frequency trading and the market data distribution within the firm. As you probably know, Barclays is large. We have both buy and sell side businesses within that. So from our perspective, we provide a service to other businesses within Barclays, and the quality of service of that is important. So that has to be monitored. Things like the tick to trade times, the order to fill times. Importantly, though, monitoring it is one aspect. So we can see what those quality levels are, but we also have to be able to understand why things have changed. So if a desk missed a trade, why did that happen? If a tick's gone missing somewhere, where did it go? Was it lost in the ticker plant? Was it lost in the colo feeding the ticker plant? Did it actually come out of the venue? Was it lost there? So a lot of our monitoring is focused around being able to do that root cause analysis to find out what's wrong, so we can remediate that and try to minimise that in the future.
Fergal, you've been around this marketplace quite a long time. What is your definition of
Yes, so that's right. Corvil has been providing monitoring solutions for several years now. A lot of our customers are in the financial trading space. We have quite a few customers who are focused on high frequency trading, so it's very latency sensitive. So really, I guess it's quite a big question. What does performance mean? Obviously, latency is a critical factor within trading, but latency itself is quite a complex beast. There are many different sources of latency within the environment, so ranging from network latency to application level latency. So latency can arise in many different places within the infrastructure, and so it's important to be able to get visibility into all of those different places. So as Richard mentioned, otherwise it's very difficult to figure out what is actually going wrong when you're not able to fill trades because of a latency problem. So revealing all of those different aspects of latency at the network level and at the application level, we've always found that to be quite important. We've also found that it's necessary to be able to show what's happening at the trading level itself. So I divide it into 3 levels really. Network level, where we're looking at what's going on in the network, round trip times, point-to-point latency between different sites, even between different firms perhaps. Then there's the application layer, where you're looking at application processing components within the trading path, and you're looking at the latency across each of those individually. And then there's the trading layer, where you're looking at the actual outcome of the trading process in terms of fill rates, in terms of the volume of trading activity, the currency value of that trading activity. And that's necessary because that's where you actually see if there is a problem within the infrastructure that's causing trading to break down, to be unsuccessful. You need to be able to see that side by side with the performance within the environment, so that you can actually see that that's happening and that it is being caused by an infrastructure problem and not by something else, such as a faulty algorithm, a flawed strategy. So that's I guess how we would summarize it. Capturing piles and piles of data is also very important because, of course, troubleshooting, being able to go back and see what happened in the past, that's vital to a lot of our customers.
Great, thank you. And Matthew, the same question to you?
That's a hard one to answer given what they said is the easy answer. I'm just going to add to that I agree with everything that's been said, but we're sort of attacking it from more of a, how do you achieve this? And I do spend a substantial amount of my time talking to clients about this, and obviously we've got a number of offerings that will actually implement some of the things that have been discussed about that I may touch on later, but we're certainly very interested in expanding the ability of our clients to achieve what my panelists have already said.
Okay, thank you. Well, let's, our session title calls out a second element to this about a modular approach. Let's peel that back a little and start again with Richard in terms of, what do you see the benefits really to a modular approach to performance?
So I think some of the benefits really come around flexibility and lowering the cost of these. I mean, traditionally, we've had to use very fixed proprietary solutions throughout, and by the time we put in all the monitoring network, by the time you've deployed taps, by the time you've deployed all the devices to capture that, you actually find out that it's cost more than the system you're actually monitoring. So consequently, you're always limited as to the extent you can do that. So that limited the capability in which you can deploy that. I think what we're seeing now is that there's becoming more options available as to how you can build those solutions. You can best fit. You can choose which ones you want to use there. And I think it's partly a commoditization of what's going on there, and I think that's really the biggest change we've seen as a result of that. That's allowing us to deploy more monitoring capabilities than perhaps we could afford in the past.
Well, Fergal, I look to you as somebody who provides both, distributed, disaggregated, as well as integrated solutions. What do you think of the modular approach?
Yeah, so I think historically we've always provided our solution in the form of an integrated appliance, so it's integrated software and hardware, and that there were good reasons for that historically. Our customers have always asked us to provide maximum performance within a relatively small form factor, and they've also been very demanding on the accuracy side. So the message rates that we have to deal with are often very high. The footprint that you can deploy within is often quite small, because if you're deploying in co-location facilities, for example, you can't afford to be taking up too much space. And the latencies that we're trying to measure are often measured in microseconds. So that combination of different things has meant historically that an integrated solution was the best way for us to deploy the analysis that we provide. I mean, we see the benefit and the value of our solution as really lying in the analysis and the software that we produce, rather than in the hardware. And I think most of our users would agree with that. But maximizing performance means that you need to have a well-balanced hardware configuration. And obviously the software configuration and hardware configuration, you need to keep it in tune. And really, to measure accurate latencies, you really needed to rely on, you needed the hardware timestamping capability, which historically has only been available in specialized hardware timestamping network interface cards. So that has been the most accurate way to measure latencies within these environments. There's also the issue of clock synchronization. Obviously, if you're measuring using different devices in different places, and you want to compare timestamps that are being made using different clocks, then you need to deal with the issue of how well those clocks are synchronized. And that, again, is something, to achieve microsecond accuracy in clock synchronization, again, you need hardware support. It can't be done purely in software. So all of that historically has meant that an integrated appliance was the most convenient way for our customers to get access to the value that we provide. Quite a number of things are changing though recently. So first of all, timestamping is becoming more widely available in, for example, AgTap devices. So devices that aggregate packet data for monitoring purposes are now able to timestamp that packet data at source. Timestamping is also available in some of the data center switches available from some of the big vendors, Arista, Cisco. So accurate timestamps are easier to get now than they were in the past. And so one of the things that we've done is that we've opened up our platform in terms of our ability to consume those timestamps that are being produced externally. Another thing that we've done is we've opened up our platform in terms of our ability to consume packet capture data that is being captured elsewhere, not on our appliance, but by other devices. And I think that just reflects the fact that the use of packet data is becoming more widespread. So the value, the visibility that packet data can provide with the right analysis, if you're able to decode the packet contents and reveal what the applications are doing, is becoming more widely recognized. So people are capturing packet data in more places, and they're asking us to allow them to upload packet data to our system and analyze it, rather than having to capture all that packet data ourselves. So we have opened up, we do see that trend towards disaggregation, if you like, the integrated appliance model starting to become a bit disaggregated. We've also opened up in terms of the results that we provide. So we actually stream all of the results that we produce in terms of decoded packet contents, application layer activity, trading metrics, and latency measurements and other performance measurements. We can stream all of that off our appliance now, because our customers want to consume it elsewhere. They don't just want to consume it all in a single place. So yes, that there is a trend, I think, towards a more open ecosystem.
Good, thank you. And it kind of leads to Matthew. I mean, Solarflare has been recently launching and expanding its performance monitoring software. What's your approach?
Well, thanks, Richard. Again, we're hearing these requests from our clients to echo what Richard said, and we're responding. We launched the solar capture range of products, leveraging our adapters, particularly the latest, greatest Flarion series. We can provide hardware timestamps. With the recent release of Solar Capture 1.3, we can provide what we feel is, a serious competitor to the existing players in the sucking frames off the network and timestamping them and passing them up through user space. We know a little thing or two about actually, getting frames off the network. And we continue to expand the product range. Notably, we have another relatively recent product called Performance Monitor, which allows hardware ingress and egress timestamps to be consumed by applications on a live server. So allowing, applications to work out what their actual latency is in very near real time, for example, or passing that information for external analysis off the box. We're very open to all this. And lastly, there seems to be a very strong trend to use commodity hardware, as the commodity hardware vendors, HP, IBM, Dell, have sort of woken up to the relatively small form factors such as 2U with lots of drive bays in it, a lot of bandwidth locally on the server, allowing packet capture appliances or servers, call them what you will, to be constructed from the same vendors that clients buy their existing servers with the support agreements and so on. So, we're really taking notice of that, and coupled with our offerings, are looking to expand that into, I call it the plumbing layer of persistent packet capture. So software image running on commodity hardware, providing extremely high performance network capture to disk with query capabilities, which forms an open platform on which people can put their own analytics. They can work with third party, we can work with third party vendors to drop their analytics on top, even do both simultaneously on the same server. So for us, this is, this has really driven the modular approach. This demand has driven a modular approach, which we think is very, very exciting. And watch this space. New products to come from us in the near future.
I think these two things. So this kind of shifts things to commodity hardware, and for us, that's really important for us in terms of being able to deploy packet capture now on commodity hardware. We couldn't do that before. I think with the advent of features like Solarflare being reliably able to capture at 10 gig line rates, that's a big change there. Likewise, capabilities Arista have put into their products with aggregation temp and timestamping. It means that we can now build monitoring networks, monitoring capabilities out of commodity products. And I think that's increasing the number of options we have available and driving down price, which are both very important for us.
One of the things I hear, with the modular approach and potential for real-time monitoring, and you've got things that we've seen in the past relative compliance checks and all. Richard, I'm kind of looking at you in terms of your concerns about the ability to scale. Do you feel that concern, and are you doing anything to try to address that kind of ability to scale with the larger? We're going to faster data rates, lower latencies. You've got a lot more information to process.
So I think things are moving up. I mean, we at 10 gig rates now, we're happy that we can do that with commodity hardware. But obviously, some of the feeds we're receiving now are on 40 gig. We're deploying 40 gig more and more now within our core network for backbone links. So I think the proprietary solutions move up the stack there, it's going to be some time before we can reliably capture 40 gig on commodity hardware. So there's going to be a need for that. I think there are. I think we're solving kind of the more common problem, which is the 10 gig LAN rates with commodity.
And Fergal, you were talking about the multiple layers of interest that you have, and I know you do quite a bit with visualization. Is that feeding into a lot of the ability to help to process this tiered layer of real-time process of monitoring them?
Yes. So once you go to a multi-layered approach, when you're actually decoding packet contents and analyzing those, producing results based on what you see in there, revealing what the application is doing, revealing what's happening at the trading layer. You start to get requests from customers, to make it all faster. So I think it's fair to say that a lot of monitoring systems of the type that we provide are optimized for accuracy, they're optimized for performance in the sense of throughput. Unlike trading systems themselves, they usually aren't optimized for latency because traditionally monitoring hasn't really been seen as being latency sensitive in the same way that trading is. Of course, you'd like to be able to see results in seconds. We do produce results in seconds, but you don't need to produce results in microseconds or milliseconds. But when you start to produce actionable information in terms of being able to identify bad orders, for example, fat finger orders, then customers start asking you to produce alerts on those in sub-second time frames. So latency starts to come into the game there.
That's right. If you can generate those kind of triggers quick enough, then we can close the loop and feed those back into our trading system. So again, it was something which wasn't possible in the past. It's now becoming possible to accomplish those.
Okay. Kind of leads into the other aspect. You're talking about time stamping and synchronization and being able to put things now distributed into the server. Matthew, I'm not sure if everybody here is familiar with the PTP protocol and time synchronization. Would you mind explaining that a little and how that helps to provide a better overall accuracy in the system?
Absolutely. Sort of very, very brief history. When I used to work at Stack, and when we started looking at benchmarks, the first thing we needed to be able to do was to measure the latencies in them. And even, this was a good number of years ago now, but even then, we really needed sub-microsecond precision and so on. And at that time, we were using sort of industrial timing hardware and so on. And we were using actually a pulse per second input, so you needed special hardware that took the signal down a coax cable and so on. And that meant that you had to wire, if you were going to do this everywhere, you'd have to run coax for the timing signals and analog amplifiers amplifying it and all that sort of, if you wanted to do it properly. And with the advent of PTP, IEEE 1588, we're essentially using the network Ethernet to synchronize machines together with pretty much comparable accuracy and precision to that offered by PPS, which incidentally is still available and still used, has its advantages. But yeah, so PPS basically, is a lovely thing which we've supported for some time in the last 2 generations of our adapter, I believe. And it basically allows you relatively easily to get the clocks synced between different adapters, and on top of that, different machines. So we don't just get the adapter timestamp synchronized, you can also get your hosts synchronized, the adapter synchronized to an external reference. So it now means that even in remote networks, you can run PTP over remote links. I mean, in a data center is one thing, but actually, between colos and things like that, PTP is valid, though, I am mindful that typically, the best precision you can get and the best accuracy you can get is essentially proportional to the jitter between the two. So it's not always perfect.
when we first came on the scene several years ago, PTP was still a great promise, but it wasn't widely deployed at that time. In the last couple of years, I think we've seen a lot more customers who now have PTP-enabled networks. So they're able to, they have hardware support for PTP in the switches in their networks. So they're able to accurately synchronize multiple devices in a very scalable way, at least within a single data center, to a grandmaster clock located in the same place. And of course, the alternative in terms of external sync is PPS, as you say. And PPS is a great technology. It's very robust, but it's just not very scalable. There's only so many sockets, PPS sockets, on a given grandmaster clock, and every device that you synchronize is going to consume one of those. So you can't distribute it over the network as you can with PTP. So it's great to see that uptake with PTP. When we started off, we actually built our own self-synchronization protocol into our software to deal with the fact that technologies like PTP at that time were not really around.
Yeah, it's important for us as well for support of some of the proprietary features. So Arista switches use a keyframe, so they can timestamp packets on ingress into their switches. So timestamping earlier is obviously better, but it's really just a 350 megahertz counter that needs to be turned back into a real timestamp. So the Aristas generate a keyframe. What's good to see is Solarflare have incorporated support of those, so that we can actually take those counters created by the Aristas and turn those into absolute timestamps when they're captured through the Solarflare. So having these people work together, which helps us create a solution then out of these commodity parts.
I wonder if you'd agree with this, Richard. I've generally found if you want to get sub-microsecond accuracy with PTP, you need to very carefully tune all the various twiddle factors that are present in the different devices along the distribution chain. You can get microsecond accuracy really easily enough, more or less out of the box.
The challenge we found is knowing how accurate our timestamps are, how accurate our clocks are. We can only compare it with somebody else and know that the two are different. We don't know which one is correct.
Yes, yeah, that's right. I mean, essentially, you need to have the way that we do it.
We're already having this situation in some of the colos where some of the venues will provide a P2P source. We get one from GPS. They're different. Who's right and who's wrong? It's the two-watch person.
We use two GPS antennas on the roof of our lab, completely independent clock sync infrastructure, and yeah, we get different results too.
Thank you. I'm mindful of our time here. Are there any questions from the audience before we ask for some closing remarks? Yes.
Hi, the question is, yes, with this market of high performance trading, there is justification to use expensive and bespoke solutions. Do you see now, because of the virtualization, but the fact that you can have the time stamping happening more, mix that would support servers that would support network functions, yeah? That then this kind of performance analytics will become more widespread for monitoring an MPLS network or an open network. But now even a commodity network has to be as cheap as possible, and monitoring solutions that is an overkill, like passive monitoring, packet capturing, is only happening in a few places, but not looking at every node in the network.
So we've always deployed them throughout the networks, but perhaps not as many as we would have liked. So I think this opens up the opportunity to deploy some of these technologies more widespread than we've been able to. Plus, I think what we're seeing is some richer software develop on those. So there is this move to actually monitor what's going on in the enterprise more, to see what's going on there. Obviously, a bank is highly regulated. We have a lot of compliancy to deal with. So being able to audit that and monitor that much more closely is actually helpful. So I think we are going to see more and more monitoring deployed in the enterprise space as well. Plus, I would say add to that as well, the applications we deploy now are much more complex, they're much more distributed. It's much more difficult now to try to debug those and find out what the cause is when something breaks.
Just to add to that, I think it's a very good question, and I do want to emphasize that our range of packet capture products and future persistent products is absolutely not tied to any specific market, and we fully anticipate there will be uptake, across the board. I think an interesting part of this that we're looking at as well is, what do you do when you're running in a virtualized environment and there's now traffic which is, within the box that you want to monitor in the same way potentially as you would externally. Now the nice thing is, from a hardware point of view, it's all in the same place, but the challenges are similar but different, and I think that's a key requirement going forwards as well. But I completely agree with Richard in that you can't monitor everything. I mean, you probably could, but it gets prohibitively expensive. So it's picking where it's important and monitoring where it is critical and crucial.
I mean, effectively what you've got down is a libpcap, which works at 10 gig wire speed. And so there's a whole host of open source software available which you can plug into that. In the past we couldn't rely on it because it just dropped too much. Now we can be comfortable that yes, we can trust what comes through there at 10 gig. So lots of open source stuff out there you can plug in and play with.
Sorry. Is most of your instrumentation, is it forensic, or is it sort of monitoring things until they go wrong? So in other words, does something go wrong and then you want to know what happened in the past, or is it looking at things, waiting for them, checking they're not going to go wrong?
So we do a lot of real-time monitoring, but so that's generating alerting and things. So that's telling you things have gone wrong. The forensic analysis tends to be after the event, trying to understand the root cause, and that's really where we want to have full captures. We can do the deep drill down into those to try to investigate those. So our experience is we need both sides of that. We need the health monitors and we need the forensic capability to actually drill down.
Yeah, that's been our experience as well. So our customers have always asked us to provide both real-time alerting based on detecting anomalous events, and also to provide large-scale data capture so that they can go back and look at what happened in the past. One of the interesting things that we've been seeing more recently is the desire on the part of quite a number of customers to look at more complex types of anomaly detection. So this would involve looking at patterns of data, building up models of activity within the system in order to detect gross deviations from what's considered to be normal behavior. So in other words, learning about the behavior of the system as it normally operates, and that can be quite complex in terms of who trades what, how much do they normally trade, what securities do they normally trade, what IP addresses do they normally use, all of those things, and then detecting any gross deviation from what's considered to be normal and alerting on that. So yeah, I think that's an interesting trend.
Okay. I'm mindful again of our time. There's nothing. Okay, yes.
Winston Career BT. So I've got two questions. So one is around, given the modularity of being able to acquire packets for monitoring versus the actual analysis, what's the appetite of consuming that as a service versus building it out, given the flexibility available? And then the second question is around PTP and its distribution. So we're interested to understand the thoughts around security, because you taking a time source of IP directly into your servers suggests that you trust that domain. You put time through a firewall, you kill it. So I'd like to understand a little bit around your thoughts around that too.
So the first one was about as a service. So for us on the high frequency trading side, that's very latency dependent. We need to very much run that on site. We are happy to take and look at managed appliances. We use those. So if somebody's providing a service to do that, it's certainly not something we would rule out. It's one of the options we consider. For us, it's very much like a buy-build decision. We'll look at the options available there and we see what delivers us best value. What was the other question? It was much more to do with the security side, or
P2P.
Oh, P2P. Yeah. So, yeah. I mean, we understand the constraints around that. In most cases, we're actually getting our PTP source from the satellites. So we get that direct from GPS. For us, then it's a matter of how do we distribute that satellite time source to the rest of our systems to keep them synchronized. So we're fairly trustful of that satellite signal.
And you have a private network, which means
Yes,
it's unlikely to be skewed.
Yes. Well, we manage that network. I mean, you're right for P2P. You've got to know exactly everything which is in path between your systems there.
Sort of very quickly from our point of view, software as analytics as a service. From our point of view, I think it's bring it on. We are aiming to provide the streams of data, our persistence is required, and yes, analyzing the streams as a service. I think the actual service bit is more sort of Fergal's domain from an analytics point of view. The PTP question is, I think, a very interesting and valid one. At the moment, many of our existing customers, like Richard, have private networks and therefore are pretty confident that people aren't spoofing things. However, I believe there is an extension. I read something about it not too long ago, supporting authenticated keys and so on within PTP. So you're not just saying, I trust this. It's does the key match, and is it a trusted source? And I think that's certainly something that everyone's going to have to look at. If a proprietary standard needs to be implemented for specific, I think that's something I suppose we'd contemplate. But I believe there are emerging general standards out there that I can say with confidence, if required, we will support.
Okay. I think we are running late, but I wanted to give each of you 30 seconds, if you will, to provide a little nugget of wisdom to provide, and if anybody's looking to implement performance monitoring systems and application latency monitoring, what would you suggest to them?
So I think, as I said at the beginning, I think that the ecosystem is opening up more. A lot of the things that used to be hard to do, like getting accurately time-stamped packet data at scale in the network, are starting to become easier. The data that's produced by a lot of these monitoring systems is becoming more open, more easier to use in downstream applications. And I'm all in favour of cheap hardware because obviously we see our value as being in the software that we produce. Hardware is a cost to us. Cheaper hardware is always good.
Thank you. And Richard?
Yeah, I think the whole kind of commoditization of this area means that we can deploy more and have more options, and that's really what we're keen to explore is how can we get benefit and business advantage from using these. So that's really what we're exploring now.
Thank you, Richard. Matthew.
And from our point of view, you know, we're very happy to be involved in this and driving it. We think we're trying to drive it to a certain extent, and we'll continue to do so. You know, we want to make it easier for people to build platforms, to do this in a very open way, and basically do more than they're doing at the moment, more flexibly. So, you know, our goal really is to just make it easier for all of you out there to start implementing, you know, solutions like this.
Okay, thank you. I want to thank our panelists. I think I neglected and overlooked Fergal Toomey, PhD, Chief Scientist and co-founder of Corvil. I forgot to mention that to you. Thank you very much. And of course, Richard and Matthew. Thank you all.